Welcome to our lesson on distance in the coordinate plane. After this lesson, I will be able to find the distance between two coordinates, and I will be able to solve real-world problems involving distance in the coordinate plane. All right, so on your first page, you're going to see that you have this table, and we're going to talk about reflections within the coordinate plane. We're going to go ahead and ignore the directions that we have right here with folding and doing all this. We're just going to talk about what happens when you reflect points within the coordinate grid. So when you reflect something, you're using a mirror, and that mirror is giving you an image from the opposite direction. So when you sit and look at a mirror, you stay the same distance away from the mirror, but now everything is turned back towards you. That's kind of what's happening when you are in the coordinate grid. So we're going to take the point 3, -2, and I'm just going to show you. You don't have to write this. I'm just going to show you so kind of exactly what it looks like when we reflect. So we have 3, we have to go to the right 3, and then -2, so we go down 2. So right now our point is in quadrant 4. Now, if I'm going to reflect across the y-axis, that means that my mirror is right here. When I reflect across the y-axis, my reflection isn't going to go up because my mirror is right here. So my reflection is going to actually go to the left because it's on the right, so it's going to go to the left. It's not going to move up and down because of the fact that there's nothing for it to bounce off of, but it is going to, instead of being on this side, so instead of being on the right-hand side, now it's going to be on the left-hand side. And it's 3 spaces away from the y-axis now, so it still has to be 3 spaces away on the other side. So now, instead of that +3, -2, now I have a -3, -2. Right? And it makes sense that, excuse me, that it ends up in a different quadrant because I'm reflecting it through the y-axis. Right? So what's happening here is you're taking it and you're saying if my mirror is on the vertical axis, it's going to reflect left to right. Now, if my mirror was on the x-axis and I was reflecting across the x-axis, now since the mirror is here, it's going to reflect it through the x-axis, meaning it's not going to move left or right, but it is going to have to move up. So it's going to have to move across the x-axis. It's 2 spaces away, and so it has to be 2 spaces away over here. So now I'm still at a +3, but now instead of a -2, I'm at a +2. Right, so let's go ahead and use that information and fill it into our table here. So notice that when I reflected it across the y-axis, it didn't move up and down at all, so my -2 stayed the same, but it did become a -3. And then here, when I reflected across the x-axis, my x didn't change at all because it didn't move left or right, but it did move up to a +2. All right, so what I want to do first is I want to reflect before we get moving on this. I want you to take a look and see if there's any relationship between the coordinates and the reflection across the axis. So do you see anything from this point and what happens when it gets reflected? And then what happens when it gets reflected? Hopefully what you noticed is that when a point is reflected across an axis, the corresponding coordinate stays the same, but the other coordinate changes to the opposite. So when reflecting across the y-axis, the y coordinate stays the same and the x coordinate becomes the opposite. This is also true for the x-axis. All right, so like I said, what you should notice is that when you reflect across the y-axis, it's your y-coordinate that stays the same, but then the other coordinate becomes its opposite. And then it's the same thing when you reflect across either axis. So just because you switch between y and x-axis doesn't mean that the thought or the process changes. So I'm going to give you a couple more coordinates, and you can try it on your own, or you can walk through one or two with me and then try the last one on your own. But always make sure to come back and check your work to be sure that you're doing it correctly. And then change it within your notes if it isn't correct, because you want your notes to reflect the correct answer. So here I have a -1, 4. And my next one is going to be a -5, 6. And then my next one is going to be -2, -9. 9 seems to get left out a lot. All right. And I'm sorry, this one was supposed to be a different color. We'll make this one purple, just so we can make sure it's easy to delineate between everything. All right, so if I'm going to reflect this across the y-axis, my y has to stay the same. So my 4 is going to stay the same because it's only moving left to right. It's not moving up and down. But my -1 becomes a 1. If I reflect across the x-axis, my x-coordinate stays the same, but then I get the opposite of my y-coordinate. Okay, again, here's an opportunity to pause and try it on your own if you're ready. Now, if I'm reflecting -5, 6 across the y-axis, the 6 stays the same, but then I take the opposite of the -5, which is +5. And then if I reflect across the x-axis, my x stays the same, but then I get the opposite of my, y-coordinate. And I actually want to take a look at this real quick. So if I go to -5, 6, so -5, 6, well actually, we'll just make it -5, 5 since I ran out of space on here. Here's -5, oops, silly me, -5, 5. So because of the fact that it is negative and positive, it's going to be in quadrant 3. We've talked about how in quadrant 4 we know that it's going to be quadrant. I got my numbers all jazzed up tonight. It's going to be in quadrant 2, and now I'm talking about quadrant 3. It has to be negative, negative. We know that each coordinate has its own special combination of positive, negative coordinates. So like quadrant 1 has to be positive, positive to be there. And then quadrant 4 has to be positive, negative. So now let's look at this 5. If it's getting reflected across the x-axis, that means it should be going from quadrant 2 to quadrant 3. So therefore, it should be going from a negative positive to a negative negative. So let's go back and check our answer. So here, it was reflected across the x-axis, and it went from a negative positive to a negative negative. So here I know that my answer is correct based on how it would change quadrants. If we look at it reflecting across the y-axis, now it's going to go from being a negative x-coordinate to a positive x-coordinate. So now it's going to be a positive positive. All right, so let's take a look. I have positive positive. So there's ways to double check my work. And then here, the last one, again, pause and try it on your own and then come back and check if you're ready. Here, my -9 would stay the same, but then my -2 would become the opposite. And then when it's reflected across the y-axis or the x-axis, my -2 stays the same, but my 9 becomes a positive. All right. So now we're going to go ahead and skip the conjecture. I want to move on to how to find distance in the coordinate plane. So we just talked about how to find reflections. Now we're going to talk about how to find actual distance. And I will tell you, we are going to be using the absolute value a ton. So I'm going to write AV with my symbol over here so to remind you that we're going to be using that. So if I want to know the distance between point A and B, I can do a couple of things. I can count and see that from 4, 3 to 4, -2, there are 1, 2, 3, 4, 5 spaces. So it moved, the distance is 5. Well, let's see, is there any way that 4 and 4 can give us 5? In this case, there isn't. But look at 3 and 2. Is there a way that 3 and 2 can give us 5? Well, it took me 3 spaces to get to the 0, and then it took me 2 spaces to get to the rest of the way to the coordinate. Well, here I'm going to 0, and then this is 2 spaces from 0. I'm talking about the distance that it is from 0, so I'm talking about its absolute value. So if I'm looking at how far is it from 3 to -2, I know that 3 is 3 spaces from 0 plus the 2 more spaces that it took to get to the new coordinate. So therefore, I know that I moved 5 spaces. Right? Again, if you connect everything, and this is only when you cross an axis, though. All right, so because of the fact that I got to 0, I was able to use the absolute value, and then I added. Right, so you're going to want to make a note of that. When crossing an axis, add the absolute value of the changing coordinate or coordinates. All right. Now, in this case, the x value did not change. Okay, so we didn't move left or right. We just went up or down. Okay, and in this case, since we're talking about from going from A to B, we can say that we moved 5 spaces down. Okay. So now we want to find the distance between points D and C. Now notice here for D and C, we don't actually cross the axis. So I can't add these numbers together because it doesn't work that way. Do notice that my y coordinates do not change because I'm not going up and down. Now I'm going left to right. All right. So what I can do though, again, if I count, we can see that it's 1, 2, 3, 4 spaces from 4 to -1. 1, 2, 3, 4. And I'm sorry, from -5 to -1. Looking at the wrong number here. So from -5 to -1, it's 4 spaces. Now, it's on a number line, so, we'd be making those jumps, and that makes sense to us. So can you see a connection between 5 and 1 that gets you to 4? All right, well, again, I want to figure out which ones are moving. So I'm going from -5 to -1. And what I can do here is I can take the absolute value of the -5 and subtract the absolute value of the -1. Right, so I'm going to take the larger absolute value and subtract the smaller absolute value. I end up getting 5 minus 1, which gives me 4. Now, in this case, it's not telling me, it's saying it's just asking for the distance between them. It's not asking how far you moved or anything. The distance between, so my answer in this case would be that there are 4 units. There we go, there's my type. There are 4 units between points E and C. And that's it. If it was asking me how I got from one point to the other, I could say, like I said up here, that I moved 5 units down. All right. So I'd like you to do here is I would like you to please try these 2 problems on your own. And then when you come back, we'll check your work. All right, so here you should have found that your y coordinates stayed the same. and it was only your x-coordinates that changed, and you're going from a -4 to a 5. This means that you've crossed the axis, and the way you know you've crossed an axis is because you went from a negative to a positive. So you went from negative world to a positive world. So, and you might want to write that down. I will quickly type it out here. Going from negative to positive, or vice versa, means you had to cross an axis. So since I had to cross an axis, I know that I'm going to add my absolute values. So I have the absolute value of the -4 plus the absolute value of the 5. So I had to move 4 spaces to get to that axis, to get to that 0, and then I had to move another 5 spaces to get to my new point, meaning the distance between those 2 points is 9 units. All right, now here, it's my x-coordinates that don't change. It's 0 and 0, but it's my y-coordinates that do. Notice they stayed negative, so I didn't cross an axis. So when the signs of the changing coordinate stay the same, that means that I did not cross an axis. And it's important to know that because that's going to tell us what operation we have to use. We're still going to use absolute value, but in this case, since I'm going from a -5 to a -10, I'm not crossing an axis, so I have to subtract. So I'm going to take that -10's absolute value, and I'm going to subtract the absolute value of -5. So here I have 10 minus 5. So it tells me the distance between these 2 points is 5 units. And again, since we're talking about distance, there shouldn't be any negative. We're just talking about how far away is it. So there's no direction to it at all. So it's just that it went 5 units. Now, I can add the direction by saying, well, since I went from a -5 to a -10, I know that I had to have gone left. But all this asks for is the distance, so we do not have to include that. All right, so here we have the coordinate plane represents a map. Each grid unit represents 20 miles. A retail company has warehouses at M, which is -70, 10, which we can see right here on our map, and N, which is 50, 10. How long does it take a truck? So here's my question. How long does it take a truck that drives 40 miles per hour to travel from warehouse M to warehouse N? Now, it's important to note that each spot represents 20 miles because of the fact that this is kind of a hard spot to plot, and each of these does not then represent 1. Each of these hash marks represents 20. All right, because in order to make it fit onto a coordinate grid, we have to shrink that space. All right, so what I'm going to do is I'm going to look. I notice that it's my y-coordinates that stay the same. I'm moving right to left. But I'm going from a -70 to a +50. Well, when I'm looking at this problem, it's important to note that these are my coordinates. It's important to note that the driver can go 40 miles per hour. And then my plan. So one, I need to find how far it is between M and M. So how far between M and N? Once I find that distance, I can take the distance and divide it by my speed. Okay, if I divide it by my speed, that'll allow me to find how long it's going to take me. All right, so here, in order to do this, I have to find how far between M and N. These have different signs, which means I'm going to add their absolute values, because it's going to take 70 to get to that 0, to get to that y-axis. Then it's going to take another 50 miles to get to N, to get to that warehouse. So I have 70 miles plus 50 miles. So that driver is going to travel 120 miles. Well, if they travel 120 miles and they take every 40 of those and put them into an hour, I know that 12 divided by 4 is 3. These two zeros cancel out. So it is going to take the driver 3 hours to get from M to N, or from warehouse to warehouse. All right, so what I'd like you to do is I would like you to solve your guided practice problems, and we will talk about these when you guys come to class. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.